Imagine waking up tomorrow morning and the sun simply is gone. Not cloudy, not night, gone. But it's still morning, and in its place, a giant and massive black hole, the same mass as our sun, sitting in the same spot, but very, very different. No light, no warmth, just darkness. Would Earth get sucked in instantly, or would something much worse happen first? Well, the answer is stranger and scarier than you imagine. So let's start from the beginning. Have you ever heard of a certain giant flaming star? Yes, the Sun. The Sun is a giant ball of hot and glowing gas. It is about 1.3 million times bigger than Earth. You could fit a million Earths inside it. But the Sun is not just big. It is the reason everything on Earth is alive. The sun sends us light and heat. Plants eat that light. Animals eat those plants. We eat those animals. The sun also keeps Earth in its orbit. Without it, Earth would just drift away. Now, what is a black hole? Think of it this way. You know how a drain works in a bathtub? A black hole is like the most extreme drain in the universe. It pulls everything toward it: light, gas, dust, time itself. And once something crosses the edge, it never comes back, ever. That edge is called the event horizon. It is the point of no return. And the black hole we are talking about? It has the same mass as our sun, the same weight, the same gravity pull. So Earth would still orbit it, exactly the same as today. The gravity would be identical. Wait, so we might be okay? Not so fast. Here is the difference. The sun gives us two things: gravity and light. A black hole? Just gravity. No light, no warmth, nothing. And that changes everything. How long until things go wrong? Here is the timeline, and it is terrifying. The moment the sun disappears, something interesting happens. Nothing. For 8 minutes. Nothing at all. Why? Because light takes 8 minutes to travel from the sun to Earth. So for 8 whole minutes, we would still see the sun. We would feel its warmth. And then, at exactly 8 minutes and 20 seconds, it all goes dark. The sky goes black. Not night black, not even eclipse black, just void. Okay, day 1. Let us talk temperature. Earth actually holds heat quite well, like a warm blanket. In the first hours, the temperature drops only a few degrees, not deadly yet. But by day 1, average surface temperature drops from about 15 degrees Celsius to minus 17. That is below freezing. Everywhere, all at once. Crops freeze. Lakes start to ice over. Pipes burst. Now, you might be thinking, we still have air. We can breathe. We are okay. True, for a while. The atmosphere protects us. But as it gets colder, the atmosphere starts to change. The oceans, the air, the very water you breathe, it all starts to freeze and collapse. First, water vapor freezes. Snowstorms everywhere, even places that have never seen snow. Then carbon dioxide starts to freeze. CO2 is what we breathe out, but it is also what keeps the greenhouse effect going, trapping heat on Earth. When it freezes, the last of our warmth bleeds out into space. By the end of the first week, most of Earth's surface is buried in ice and snow. Average surface temperature? Minus 50 Celsius. That is colder than Antarctica in winter. At this point, food production above ground is basically over. Plants need sunlight to grow. No sun, no plants, no food chain. The only food left? Whatever we had stored, whatever was underground. Fish deep in unfrozen ocean pockets. But wait, the ocean, could that save us? Here is a surprising fact. The deep ocean holds enormous heat. It has been storing warmth from the sun for millions of years. It would take a very, very long time to freeze all the way down. Scientists think the deep ocean could stay liquid for over 1 billion years. So life in the deep sea might actually survive. Hydrothermal vents, bacteria, little creatures in the dark. And what about us, humans? Could we survive? Here is the interesting part. Some scientists actually think small groups of humans could survive underground, near geothermal vents. The Earth's own core is still hot. It will stay hot for billions of years. If we could tap into that heat, we might just make it. But here is the real terrifying question. What does the black hole actually do to us? So, Earth still orbits. That part is fine. Same path, same distance. But we are now bathed in something called Hawking radiation. Hawking radiation is the tiniest trickle of energy that a black hole leaks out. It is so small, so weak, you would barely notice it. But we would notice this. The tidal forces near the black hole are extreme. Tidal forces. The closer you get to a black hole, the stronger its pull. But at Earth's distance, the same distance as the Sun, the tidal forces are about the same as the Sun's. So from our orbit, the black hole is not trying to rip us apart. We are safe from that. Here is where things get very interesting. Our black hole has the same mass as the Sun, but what if it is actively eating nearby gas? An active black hole with an accretion disk? It can blast out more energy than the Sun ever did. X-ray bursts, gamma-ray jets. This is what we call a quasar at its most extreme. And even a small version of that, it would strip away what is left of our atmosphere. No atmosphere, no air, no pressure. Earth becomes like the moon, but colder. And there is still one more twist, the most terrifying one. You know what black holes do to time? They bend it. The closer you are to a massive object, the slower time moves for you. This is called gravitational time dilation. If you flew close to the black hole and came back, years would have passed on Earth while only hours passed for you. That is not science fiction. That is literally how the universe works. And then there are the jets. Some black holes shoot out massive beams of energy from their poles. If Earth happened to be lined up with one of those jets, one word, goodbye. But our black hole is probably quiet, probably not shooting jets, probably. If we somehow survived underground, if we built our civilization in geothermal caves, Earth could orbit this black hole for billions and billions of years. Eventually, even the black hole would die. A black hole's lifetime is almost impossible to imagine, 10 to the power of 67 years. But once the black hole is gone, Earth would float off, into nothing, the ultimate final freedom. Okay, let us bring it all together. If a black hole replaced the Sun tomorrow with the same mass, Earth would keep orbiting, same path, same speed. Gravity, same. No spaghettification from this distance, no ripping us apart. But light, warmth, photosynthesis, all gone, within hours. Within a week, the surface is a frozen wasteland. Within months, the atmosphere may begin to freeze. Within years, the surface of Earth becomes the coldest, darkest, most isolated place you can imagine. But the deep ocean, the geothermal vents, life might hold on down there for billions of years. Here is the big idea I want you to take away from this. The Sun is not just a ball of light in the sky. It is a machine, a life support machine, built for us, or rather, we were built for it. We take for granted that it rises every morning, that it will be there. It has been burning for 4.6 billion years, and it has about 5 billion years left. That is a long time. We are exactly in the middle of its life. And in the entire history of the universe, we happen to exist right now, in this tiny warm window. So maybe the real lesson of replacing the Sun with a black hole is just how lucky we are that it is the Sun.